Today we're going to start talking about ionic compounds, and we're going to be talking about both ionic and covalent compounds over the next few weeks. What we do this week will set everything up for the rest of the year. What I teach you in regard to naming ionic compounds and writing their chemical formulas is critically important for success in chemistry from here on in. Your learning goal is for both chapters 5, which is on ionic compounds, and chapter 6, which is on covalent compounds. And you've had some background in this in middle school, but we're going to take it to a new level. It says through inquiry and exploration, students will be able to understand that bonds hold elements together in specific ways. We're going to explore both ionic and covalent to form new compounds that are then represented by specific chemical formulas and nomenclature. You're going to learn how to write chemical formulas. For example, magnesium chloride is MgCl2. You're going to take a look at these compounds in different products in your house, from cleaning products to beauty products to medications, etc. And then we're also going to get into drying the compounds for covalent compounds. So there's a lot we're going to be talking about in the next month, and I'm going to test these two chapters together. So that's your learning goal for the next two chapters. And today we're going to start to introduce ionic compounds. And a lot of what we introduce today you could see on your test on Wednesday. So there'll be some good review material in here to set you up for success on Wednesday. The first thing we want to do is we want to compare ions and atoms. We know ions are charged particles, and they are charged particles because they have lost or gained one or more what? Electrons. So we know we don't lose protons. Proton number never changes because protons matches the atomic number. That is the identification tag for an element. So an ion is a charged particle that forms through the gain or loss of one or more electrons. Sodium. We're going to look at sodium and the sodium ion it forms due to the loss of one electron. The electron on the right side of that equation signifies a loss of one electron. Sodium ion is a cation ion. Remember, we said cats have paws. Cations are positively charged ions. We're going to look at properties of electron configuration. That is from chapter 3. We're going to look at protons, electrons, neutrons, and charge. That's from chapter 2. The radius from chapter 4. The stability will be the new piece of the puzzle. So for example, a sodium atom has the electron config 1s2, 2s2, 2p6, 3s1. Looking at that electron configuration and not looking at a periodic table, you know that sodium is in what period of the periodic table? Jarrett?
2.
Why?
1. No, 2. Because 2. 2s.
The highest value of N in that electron configuration is?
3.
3. So sodium is in the third period. So the highest value of N is 3, and sodium is in the third period. What group is sodium in?
Group 1.
Group 1. And that family is known as what?
Alkaline.
Alkali metals. All right, so these are all questions you can see on your next test. So you really want to be comfortable with this type of analysis, and we'll do some multiple choice questions for review before you test. So sodium will lose its one electron from the 3s orbital to form a sodium ion, 1s2, 2s2, 2p6. How many electrons does the sodium ion have?
8.
2 plus 2 is? 4 plus 6 more is? 10. So the ion has 10 electrons, the atom has 11. The atom has an equal number of protons and electrons, so it has no charge. It's electrically neutral. The ion has 11 positive charges and 10 negative. So what's the overall charge on the ion?
Positive.
1 plus is correct, or just plus. Neutrons, how do you get neutrons? Mass number minus atomic number or protons. So 23 minus 11 is 12. Again, review from chapter 2. Chemistry is all going to come together as we go. It's going to build, build, build. Some of what you learned at the beginning is going to come back again and again and again. It's like algebra. If you can't add, subtract, multiply, and divide with ease, your algebra is going to be extremely messy. One other word that's here that will be new to you is isoelectronic. What does the prefix iso mean? ISO means? ISO means? Think about an isosceles triangle. So an isosceles triangle has two sides that are the same, two angles that are the same. Isoelectronic means the same electron configuration. So this is a sodium ion, and neon would have the same electron configuration. We're going to explore isoelectronic in a little more detail in a few minutes.
Wait, what does it mean?
Isoelectronic, it's listed below here, and I'm going to go through it. It means that usually two ions or an ion and an atom have the same electron configuration. Isoelectronic means the same electron configuration. Now the radius of an atom can be compared to its ion. When you form a cation, do you lose or gain electrons? Lose. Remember, the plus sign has 4 L's in it. So a sodium ion has lost 1 electron. So you now don't have any electrons in the third shell, which are farther from the nucleus with more electron shielding. As a result, the ion's radius will be less than that of the atom. So a cation will always be smaller than its corresponding atom. And stability-wise, the ion will be much more stable, and it'll be similar in stability to the noble gas with which it's isoelectronic. So how many electrons are in the second shell of the sodium ion? 8. And what you're going to see is something called the octet rule. Ions form through the loss or gain of 1 or more electrons so that they have 8 electrons in their outermost shell. That confers stability. So for a cation, the cation will have a smaller radius than its corresponding atom, but the ion is far more stable than the corresponding atom because it has an octet of electrons in its outermost shell. In contrast, atoms can gain 1 or more electrons to form anions. So for example, chlorine will gain 1 electron, the electron's on the left side of the equation, to form the chloride ion. Chlorine's electron config 1s2, 2s2, 2p6, 3s2, 3p5. Without looking at a periodic table, in what group is chlorine? Group 17 is correct because it has 2 plus 5 is 7 valence electrons. Group 17 has 7 valence electrons. When you go to study for your test on Wednesday, you really want to go back and look at that table that you submitted to me last Wednesday, because that will help you organize your thoughts and it will be very good for you. Make sure that you look that over. It's a good way to study for your test. So chlorine has 17 protons. How many electrons would it have?
18.
The atom would have?
17.
17, so its charge would be? 0. Neutrons, mass number 35 minus atomic number 17, 18 neutrons. The ion has gained how many electrons? 1 is correct, so it will have how many electrons?
18.
18, and its charge will be 1. This is correct. Now the radius of the anion is larger than the corresponding atom because it's gained an electron without a change in the number of protons. So you have the same number of protons acting on an additional electron. You also get electron-electron repulsion in that third shell, and that ion's radius is larger. And why would the stability of the ion be greater than that of the corresponding atom? How many electrons are in the outermost shell of the ion? 8. So that's that octet of electrons. And why is a chloride ion isoelectronic with argon? They have the same electron configuration. You got it. And we're going to get into that a little more here. So some basic terms that you want to be familiar with. The first one is electroneutrality. This one I think will be the toughest for you initially because it's not going to make full sense till you learn how to formula right next time. But I'll provide you with a few examples just to introduce it here. And then next time when we write chemical formulas, I think you'll be more comfortable with it. So in regard to electroneutrality, with electroneutrality, it says cations are never found without an equal number of anions such that the overall charge is 0. Another definition that doesn't mean anything. So let's try and come up with some examples so we understand. Sodium chloride is table salt. This is what you salt your food with. This is the salt that is in many of the foods that you eat. Don't want too much salt in your diet, not especially good for you. This is an ionic compound. The ions that make up this compound are sodium ion and chloride ion, and you'll learn how to determine that next time. We have one sodium ion with a 1+ charge, and we have one chloride ion with a 1- charge. If I add those together, the sum is 0. So we have 1+ overall, 1- overall for a net 0. Electroneutrality, the same number of plus as we do minus. For example, let's say that we had magnesium bromide, and you'll learn how to write these chemical formulas and name them next time. And I've got a very interesting project for you to work on over the second 9 weeks to make sure you understand the similarities and differences between ionic and covalent compounds, something like carbon dioxide. So we have one magnesium ion with a 2+ charge because it's in group 2. We'll get into the charges in more detail next time. And 2 bromide ions. Group 17 has 7 valence electrons. They will gain 1 to have an octet of electrons in their outermost shell. So we have 1 2+ and 2 1- for a net equal to 0. So we have 2 pluses and 2 minuses. Electroneutrality, same number of plus as minus. And then finally you could have something like this, aluminum sulfide, where you have 2 aluminum ions. I don't want you to be able to do all this yet. I just want you to see that the sum of the charges is 0. And 3 sulfide ions. So we have 2 3+ and 3 2- for a net of 0. So we have 6+ and 6-. That's electroneutrality. In a compound which is electrically neutral, you have the same number of positive as you do negative. The second term I want to introduce to you, and again, we'll be using this one, you're going to see a lot of as we go through the chapter, The other term is isoelectronic. And we said isoelectronic means that two or more species have the same electron config. It can be an atom and an ion. It could be two or more ions. And what you're going to see is that cations of representative elements, in what blocks are the representative elements? Representative or main group elements are in what blocks? S, N, P. All right, you'll need that for Wednesday. So cations of representative elements are isoelectronic with the preceding noble gas. So let's put that into English. Let's say that we're looking at a periodic table and we're going to focus, for example, on a sodium ion and a magnesium ion. Sodium atom with 11 electrons is 1s2, 2s2, 2p6, 3s1. The sodium ion will lose one electron. It'll lose the electron from the 3s orbital, and it has this electron configuration as we discussed previously. How many electrons for a sodium ion? 10 is correct. What element on the periodic table has an atomic number of 10?
Neon.
Neon. And if we were to write the electron config for neon, it'd be 1s2, 2s2, 2p6. So we say that neon and the sodium ion are isoelectronic. Now, if I wrote the electron configuration for a magnesium ion, magnesium has 12 protons. How many electrons would a magnesium ion have? 10 is correct. So this is also isoelectronic with this and that. They all have the same electron configuration. Now, cations have the same electron configuration as the noble gas in the preceding row. So if you have a sodium ion and a magnesium ion, to find what they're isoelectronic with, you're going to go all the way across and up one, and you will find that that works. So if you have a potassium ion and a calcium ion, those ions will be isoelectronic with argon. If you had a cesium ion and a barium ion, what would those ions be isoelectronic with? Xenon. So it's in the preceding row for a cation. So on the left side of the periodic table where you have metals and they lose electrons to make cations, they're isoelectronic with the noble gas in the previous row or period. Now on the right side of the periodic table over here, do we have metals or nonmetals?
Non-metals.
Nonmetals. And nonmetals will gain electrons to form anions. So they will be isoelectronic with the noble gas in the same period. Let's take a look. Let's say, for example, we had a sulfide ion. Sulfur has 16 protons. How many electrons would a sulfide ion have? 18 is correct. 1s2, 2s2, 2p6, 3s2, 3p6. And that electron configuration matches which noble gas?
Argon.
Argon is correct. Is argon in the same period as sulfur?
Yeah.
Yes, it is. So a sulfide ion has gained 2 electrons, go to the right 2, and it is isoelectronic with argon. similarly, if I had a chloride ion, 17 protons, 18 electrons, same electron config, we say that these three species are isoelectronic. They have the same electron configuration. So these three have the same electron configuration. So anions are isoelectronic with the element at the end of the period. Cations with the element at the end of the period, but in the preceding period. Uh-oh. Dylan, did the other piece fall out by you? I don't see it.
I don't see it. Maybe it went under your printer.
I know. It'll still work. I'll find it. It's okay. All right. So isoelectronic is another term for today, and the last term is the octet rule. And with the octet rule, what you're going to see is that, especially in the case of ionic compounds, ions will lose or gain one or more electrons so that they have the same electron configuration as a noble gas. They'll have an octet of electrons in their outermost shell. So they will lose or gain one or more electrons so that they have the same electron configuration as a noble gas. And you saw that in your lab as well. All right, so let's look at tendencies of elements on the periodic table, and it's different for metals and nonmetals. But before we go on, are there any questions?
Can you go over that last thing, that octet rule?
In regard to the octet rule, you can see it right here. So for example, sodium will lose its electron in the 3s orbital so that it has an octet or 8 electrons in its outermost shell, which now will be the second shell. You will see that sulfur forms sulfide ion. It gains 2 electrons, so it now has an octet of electrons in the outermost shell. So atoms will lose or gain 1 or more electrons, so it has 8, an octet of electrons in its outermost shell. And that's all it's saying.
You said that has 8 valence electrons.
Now it does, yep. Same electron config as a noble gas.
Okay. And I have one more question. Couldn't you make any element isoelectronic just by like adding or taking away electrons, like however many you want?
Probably. But what you're going to find is that based on the element's location on the periodic table, that will predict what ion it will form. So sulfide ions are always 2-, they're not 1-. Chloride ions are always 1-, they're not 2-, 3-, or 7+. So especially for most main group elements, you will be able to predict its charge based on its location on the periodic table. Okay, what you're going to see is that metals tend to lose 1 or more electrons. They're going to form cations. If you were looking at a periodic table, for example, like the one shown here, where are the metals? On the left side or the right side? Left. And most elements on the periodic table are metals. You're going to want to remember that. So you have metals. Metals tend to lose 1 or more electrons. If you lose electrons, do you form a cation or an anion? Cation. And that's what you're going to see. So metals tend to lose 1 or more electrons, forming cations. For example, sodium is in group 1. How many electrons will it lose? It has 1 valence electron, so it's going to lose 1 and form an ion with a 1+ charge. calcium loses 2 electrons and forms an ion with a 2+ charge. Aluminum loses 3 electrons and forms aluminum with a 3+ charge. Transition metals are similar, but they have the ability to form ions of multiple charges. Most transition metals form cations. There are a few exceptions. We're not going to deal with the exceptions. But the D block elements, where's the D block?
That one.
Where's the D block? What color?
Green.
Green is correct. So this is the D block here. Your transition elements. Where are your inner transition elements? Right there? That's the F block. Okay, because you want to know that for Wednesday as well. Now your transition metals have the ability to form cations of multiple charges. How many valence electrons do transition elements have usually?
3.
2 is correct. And they will often form ions of 2+ charge, but some have the ability to form 2+ or 3+. Some have the ability to form 1+ or 2+, and some, like chromium, have the ability to form 2+, 3+, or 6+. So, for example, titanium can form a titanium 2 ion or a titanium 3 ion. We'll get into the naming shortly. Copper can form a copper 1 or a copper 2. Chromium's very interesting. It forms a 2, a 3, or a 6. And these ions can be very different, and some of them can be very deadly. Raise your hand if you've seen the movie Erin Brockovich. Julia Roberts. It was very good. I'm not a big watcher of scientific related movies. I don't like sci-fi, and I certainly don't like to read most science books, but this was a very good movie. It's about a woman who is hard on her luck. She had had an accident. She went into a law firm, and she sort of squirmed her way into a job, not as a lawyer, more as a secretary. But she started to look through some files, and she noticed that in one small rural area where a lot of people were developing rare cancers, their children were being born with deformities, and she started to wonder why. She wondered if maybe there was something environmental that was causing some of these cancers. And she did a lot of legwork, and I don't want to give the whole movie away because it really was very good. It is rated R, so you do need your parents' permission. There is some inappropriate language in it, and there is some inappropriate attire, so things that you wouldn't wear to school and get away with. But in any event, chromium 6 ion is known as hexavalent chromium, and it is a carcinogen in the water supply. And they were able to do some research and show that hexavalent chromium was in fact in the water supply, and it was responsible for this, and that was due to some illegal discarding of material by a chemical company. So I do recommend the movie. It's very good.
Wait, what's it called?
It's called Erin Brockovich. And actually her name was mentioned recently because when they had that potential cancer cluster up in the acreage, her name came up because she was one of the people who came down here to see what was going on. But the movie is very good. I do recommend it. In any event, transition metals can form ions of multiple charges because not only does it lose its valence electrons, it also can lose electrons from d orbitals. There are some exceptions to those cations. We're really not going to get into them. The inner transition metals are all 3+. We're not going to deal with them, so we're not going to worry about it. Rhenium is a transition metal, but it actually forms a 1- charge. Rhenium is right here. Again, we're not going to play with that one, so we're not going to worry about it. Nonmetals on the right side of the periodic table tend to gain one or more electrons, so they're going to form anions. For example, nitrogen is in group 15. How many valence electrons? 5. So how many electrons would it gain? 3 is correct, forming a nitrite ion with a 3- charge. We'll go into the naming in a minute. Oxygen in group 16 has 6 valence electrons. It will gain how many?
2.
And then bromines in group 17 with 17 valence electrons, it gains
1.
correct. And then the last thing I want to mention today, we'll get into the hardcore naming after your test on Wednesday. I want to go over how to name ions, just ions today. Cations, which is super easy, anions, which is a little more challenging. What you're going to see with the cations, for example, is you're going to name the element followed by the word ion. So take a look at these 5 for just a minute. So we have potassium ion. 1 plus charge loses 1 electron. Lithium ion, calcium ion, magnesium ion, aluminum ion. So they each are the name of the element followed by the word ion. Your S block elements that form cations, very easy. Name of the element, ion. Aluminum also, very straightforward. Some of them are not as straightforward because they have the ability to form multiple cations, and you have to specify which one it forms. So it says if an atom can form more than 1 ion, which most transition metals can do, and some metalloids acting as metals can do, and some metals such as tin and lead under the stair-step line in the P block can do, you have to indicate the charge using a Roman numeral. And I do want to specify Roman numerals because this came up the other day as well. For example, this Roman numeral is a,
9.
that's
Not
why
9.
we're going over
4.
it.
4.
4.
I meant 4.
This is a, and this is a,
6.
and the kids sometimes confuse the 4 and the 6, so you really want to be comfortable with that. It could be costly on a quiz. Make sure you're comfortable with it. So when you need to specify the charge, typically you need to for transition elements with a few exceptions. I'll go over the exceptions next time. And tin and lead especially, be careful there. You write copper, Roman numeral 1 in parentheses, ion. You say copper 1 ion. Copper 2 ion, iron 2 ion, iron 3 ion, where the Roman numeral is the charge on the ion. These are all cations. Chromium, what would this be? 2 is correct. And then chromium 3, and then chromium 6 is correct. Tin 2, this would be tin 4, and this would be lead 2, and then lead 4. So the Roman numeral specifies the charge on the cation's charge. The last piece of the puzzle today are your monatomic anions. These must be memorized. You must memorize these. If you have monatomic anions, what you're going to see is a single atom with a charge. So monatomic 1 with a charge, as opposed to polyatomic, which we'll hit on Friday. For your representative or main groups, the ending of these monatomic anions is always IDE. So F minus is fluoride ion. Let's take a closer look at group 17. For example, F is fluorine. it gains an electron, and here's your fluoride. Note the spelling. Spelling's going to count on this upcoming quiz. Ends in IDE. Cl is chlorine. Cl minus is a chloride ion. And both of those are ions, so you'd specify as such. Ends in IDE. So for group 17, the ione just becomes IDE, and group 17 has a 1 minus charge. How come? It gains 1 electron to complete the octet in the outermost shell. So you've got fluoride, chloride, bromide, and iodide ion from group 17 shown in blue. Those are the easiest to remember. Group 16 and 15 is a little tricky. Oxygen becomes oxide ion, sulfur becomes sulfide ion, selenium becomes selenide ion, and tellurium becomes telluride ion. These all have a 2 minus charge because they've gained 2 electrons to complete the octet in the outermost shell. They had 6, they gained 2. Group 15, you've got phosphide, nitride, and arsenide ion for phosphorus, nitrogen, and arsenic. And that's why I said these endings just need to be, you need to know the monatomic anions. It's something you want to memorize, certainly for Friday, preferably for Wednesday, but you have a test Wednesday, so you probably won't look at it. If H forms an anion, it is a hydride ion. If carbon forms an anion, C4 minus, it gains 4 electrons, it's a carbide ion. So you want to learn your monatomic anions. It will be very helpful to you in regard to formula writing. What we're going to do in your next class is learn how to write chemical formulas. So if I say to you, you have sodium oxide, you're going to learn how to write its chemical formula. If I say to you, you have calcium fluoride, you're going to learn how to write its chemical formula. If I tell you that this is your compound, you're going to learn how to name it. And that will be our lesson next time, and that's where it really gets a lot more fun. Looks hard. I promise it'll be extremely easy for you with practice, but you have to be extremely strong with it. So for today, you're getting a brief introduction into ionic compounds. Ionic compounds are formed through the transfer of electrons. You've got a cation and an anion, and we're going to figure out how to balance them out so we can write chemical formulas and name compounds. Questions? Got it? Okay. So you did a really good job, and I will end.